So let's kick things off by reviewing what a polynomial is. A polynomial is an expression with multiple terms. A term can be a constant, a variable, or a multivariable monomial. So this polynomial in front of us has three different terms that are examples of each of these. Negative 2x cubed yz is one term with multiple variables. They're all being multiplied times each other, so it's all considered one term. This would be a multivariable monomial. 7x is an example of another term. We have a coefficient 7 being multiplied times a variable x. And 4, which is a constant, and together all three of these terms constitute a polynomial, multiple terms. Throughout this video, we'll be discussing how to go about adding, subtracting, multiplying, and dividing polynomials. But first, let's continue discussing what constitutes a term that's allowed to be in a polynomial. In the denominators, for example, a term can be divided by a constant but not by a variable. So we cannot have variables in our denominators. The exponents of the variables can be equal to 0 or a positive integer, but not a negative value. So 4xy squared divided by 3 is a term that would be allowed in a polynomial. In the denominator, we have just the constant 3. There's no variable in the denominator. But if we change the denominator to a variable z, this term would not be allowed in a polynomial. And if you have both a variable and a constant in the denominator, this term would not be allowed either because the variable is in the denominator. Even if this is written with z in the numerator, if it had a negative exponent, that would not be allowed as well. Z in the denominator is equivalent to z to the negative 1 in the numerator, so keep a lookout for that as well. None of the exponents for variables are allowed to have a negative value. Remember that. A radical sign is the result of a fractional exponent. A constant in a polynomial can have a fractional exponent, but a variable cannot. So the square root of 5 and the square root of 9 are allowed to be a part of the terms in a polynomial. But the square root of x or the square root of x times y squared times z, none of these would be allowed because these variables would then have exponents that are fractions. Variables cannot be in the denominator, and variables cannot have fractional exponents. If so, then that term cannot be a part of a polynomial. So you will not see any expressions with these types of terms throughout this chapter. Now there are some special polynomials that you will see frequently. A polynomial is also known as a monomial if it has one term. So for example, the constant 3 is a monomial. 4x, a coefficient of 4 times the variable x, is considered a monomial. They're being multiplied times each other. So this product is considered a singular term. And negative 7x y squared z cubed, they're also being multiplied times each other. So this is all considered one term. And a singular term, again, is considered a monomial. A polynomial is also known as a binomial if it has two terms. So a couple examples of binomials. One example would be 6xy plus 11. So we have one term, 6xy, and another term, the constant 11. Together, this expression would be considered a binomial, a polynomial with two terms. The coefficient can also be a fraction. So negative 13x over 2 is considered a singular term, minus yz. These are being multiplied, so it's also considered a singular term. So two terms would give us another example of a binomial. And a polynomial is known as a trinomial if it has three terms. So x squared plus 5x minus 8 would be one example of a trinomial. And 5x squared plus 6y minus 2 would be an example of another trinomial. So we'll be discussing how to go about using the basic operations with all these types of polynomials throughout the remainder of this chapter. Let's now discuss the degree of a polynomial. The degree of a polynomial refers to the order of the expression, not an angle. The degree or order of a polynomial with only one variable is equal to the largest exponent. So for example, if we had this polynomial here, 9x cubed minus 4x squared plus x minus 2, we're going to look at the individual terms in the polynomial, and the degree of this entire polynomial will be equal to the largest exponent. So we'll start with our constant, -2. Constants all have a degree equal to 0. We then look at the next term, x. This x has an exponent of 1, so the degree of this term is equal to 1. Then we have -4x squared. The constant has a degree equal to 0. The variable x has an exponent equal to 2, so this term has a degree equal to 2. And 9x cubed, 9 has a degree of 0, x has a degree of 3, so this term has a degree of 3, and the degree of the entire polynomial is equal to the degree of the largest exponent. So the degree of 9x cubed minus 4x squared plus x minus 2 is equal to 3. And you represent the degree of a polynomial by putting the polynomial inside a pair of parentheses and preceding that expression with DEG for degree. So the degree of this polynomial is equal to 3. If you were given the polynomial x to the 7th plus 3x to the 4th minus 11x, the degree of this expression would be equal to 7, since the largest exponent in the expression is 7. This variable has an exponent of 1, this variable has an exponent of 4, and this variable has an exponent of 7, and the degree or order of a polynomial with only one variable is equal to the largest exponent. So we only have x in this polynomial, and the largest exponent is equal to 7. So the degree of the polynomial is equal to 7. Another example, if we had x to the 8th minus 2x cubed plus 9x squared, this term, 9x squared, has a degree equal to 2. This term, -2x cubed, has a degree equal to 3. And this term, x to the 8th, has a degree equal to 8. So the largest exponent in the polynomial is 8. So the degree of the polynomial is equal to 8. So that's how you find the degree of a polynomial that only has one variable. Some special polynomials. A constant, again, which is a number, has a degree equal to 0. A polynomial is considered linear if the largest exponent in the polynomial is equal to 1, such as x minus 1. The exponent of x here is 1, so the degree of that polynomial is 1. You also have quadratics that have a degree equal to 2 because the largest exponent in the expression is equal to 2. So x squared minus 9, for example, is considered a quadratic expression, and quadratics have a degree equal to 2. And you also see variables that have a degree equal to 3 pretty frequently throughout algebra. These expressions are considered cubic, such as x cubed plus 1. So these are just a few of the different types of polynomials that you'll come across pretty frequently throughout algebras 1 and 2. Now let's discuss how we find the degree of a polynomial that has more than one variable. If a polynomial has more than one variable, then the degree will be equal to the largest degree in the polynomial. So let's say we had the polynomial -3x squared y plus 2x cubed yz minus z to the 4th plus 6. The degree of this expression is equal to 5. But how do we find the degree since we have 1, 2, 3 variables throughout this polynomial? Well, The degree of a single term with multiple variables is equal to the sum of the exponents in the term. So let's look at this step by step. Starting furthest to the right, we have a constant 6. Constants have a degree equal to 0. So we'll look at the next term, z to the 4th. The degree is equal to 4 since the exponent is 4 and we only have one variable. And then we have 2 times x to the 3rd times yz. This term has a degree equal to 5. If we add up the exponents for the three variables, z has an exponent of 1, y has an exponent of 1. Remember, anything to a power of 1 is just itself. So when you don't see the exponent is 1. So we get 1 plus 3 plus 0, and that would be equal to 5. And then lastly, we have negative 3x squared times y. If we add up the exponents, we get 1 plus 2 plus 0, which would be equal to 3. So when we find the sum of the exponents for each term, that shows us that the degree of this polynomial is equal to 5. We had a degree of 0, a degree of 4, a degree of 5, and a degree of 3. So the largest degree in this polynomial is 5. So the degree of the entire polynomial is equal to 5. So when you want to find the degree of a polynomial, you find the sum of the exponents for each term. Let's now have you try a few practice questions. Question number 1. Find the degree of 4x to the 5th minus x cubed plus 6x. Question number 2. Find the degree of 6x to the 3rd minus 5x to the 2nd y to the 2nd plus 7xy. In question number 3, find the degree of negative 5xy squared plus 4y to the 2nd z to the 2nd minus 3x to the 3rd z squared. Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1, we had the polynomial 4x to the 5th minus x to the 3rd plus 6x. To find the degree, we want to find the sum of the exponents for each term. So this first term, we have 6x. The exponent for the x is 1. So the degree of this term is equal to 1. Then we have x to the 3rd. This variable has an exponent of 3. So this term has a degree equal to 3. And then we have 4x to the 5th. X to the 5th has a degree equal to 5. So since this is the largest degree of the polynomial, then the degree of 4x to the 5th minus x to the 3rd plus 6x is equal to 5. Question number 2. We were given the polynomial 6x to the 3rd minus 5x to the 2nd y to the 2nd plus 7xy. So let's find the degree of each term. We have 7xy. So the sum of the exponents would be equal to 1 plus 1, which is 2. So the degree of 7xy is equal to 2. Then we have 5x squared y squared. The sum of the exponents for the variables is 2 plus 2, which is equal to 4. So the degree of this term is equal to 4. And then the third term, we have 6x to the 3rd. The variable has an exponent equal to 3. So the degree of this term is equal to 3. So we have a degree of 3, a degree of 4, and a degree of 2. So the degree of the entire polynomial is equal to 4. In question number 3, we were given negative 5xy squared plus 4y cubed z minus 3x cubed z squared. The degree of 3x cubed z squared is equal to 2 plus 3, which is equal to 5. The degree of 4y cubed z is equal to 1 plus 3, which is equal to 4. And the degree of negative 5xy squared is equal to 2 plus 1, which is equal to 3. So we have a degree of 3, a degree of 4, and a degree of 5. So the degree of the entire polynomial is equal to 5.